Hi, my name is Krista Dietrich, and I'm going to attempt to explain how the leucine zipper is held together, and also what an electrostatic interaction is. So after a little bit of research and doing the reading, I found out that the leucine zipper is created by the dimerization of two specific alpha helix monomers bound to DNA. The leucines are hydrophobic, which causes the alpha helices to be zippered together by hydrophobic interactions. At the end of the helix is the DNA binding regions, which contains basic amino acids. The leucine zipper is a type of transcription factor, and for those of you that don't know, a transcription factor are proteins that bind to specific sequences of DNA to modify transcription. I think that another amino acid that could pair side chains and interact in a similar manner as lysine or glutamate would be valine or valine. And the reason I believe this would be a good amino acid is because it has very similar features. For example, it is hydrophobic, just like lysine and glutamate, and it also has nonpolar tails as well. Valine is also a simple amino acid, and like I stated earlier, it has a very similar structure to leucine and glutamine as well. For the second part of the presentation, I'm going to describe what an electrostatic interaction is, and it's also known as the van der Waals interaction, which is the attraction or repulsive interaction between electrically charged objects. There are polar ends, which are covalently bonded with nitrogen and hydrogen and allow for hydrogen bonding and base pairing with the DNA double helix. An example of an electrostatic interaction would be walking across the carpet with your socks on and then touching the doorknob. So it's the transfer of the electricity from your feet to the doorknob, which shocks you. All right, well, I hope you all have a good night, and I enjoy looking at your guys' videos.